Hello students, I'm sorry that I can't be with you today, but I'm going to leave you a series of several videos to introduce the topic of logarithmic functions. And I know that you've talked about logarithms before, you would have done it back in Algebra 2, and I also am very aware from teaching this topic for a long time that it's not always students' favorite topic, that it can feel a little bit confusing. But what I want to point out here is that logarithmic functions are simply, so just as a start here, logarithmic functions are simply the inverses of exponential functions. So we've been talking about exponential functions, and now we want to talk about the inverse function. So before we get into the notes here, I want to go back here and do a little opener problem with you. And so I would invite you, please, as we do this, just take out a plain sheet of paper for yourself and work the problem like you would if you were in class and I sent you to the board to do it. Turn off the video after you see what the problem is and try the problem yourself, and then come back and watch the solution. So just a little review of inverse functions, which is something that you did back in chapter 2. So we're just going to take a simple linear function. Let's let f of x equal 4x plus 2. And we want to find the equation for the inverse function, and the notation that we use for the inverse function is that f prime of x notation. So like I said, I would invite you to jot down the problem, turn off the video, try it yourself, then turn the video back on, and then I will take you through it. Okay, so if you are back and listening to this, hopefully you've already tried this problem yourself and that you remembered how to find the inverse function. So if you have f of x is equal to 4x plus 2, usually the first thing that I do is replace the f of x with y. Excuse me. All right, and then to do the inverse, you probably remember that basically what you do is you switch the x's and the y's. So we're just going to reverse those. So that means that then that the inverse will be x is equal to 4y plus 2. All right, so that is the inverse. But now what we usually want to do is put it back into function notation, and so we want to solve for the y. We want to get the y by itself. So that means that I will subtract 2 from both sides, so that will give me x minus 2 is equal to 4y. And then you can either think of this as dividing by 4 or multiplying by 1/4, either one. And so on this side, we just get these will cancel out, so we get y. I'm going to switch it over to this side, equals. And then you can either write it as 1/4 times the quantity x minus 2, or if you want to think of that x minus 2 as being x minus 2 over 1, you also could write it as x minus 2 over 4. Okay? And then the notation for that is, we replace the y then with f inverse of x is equal to x minus 2 divided by 4. Okay? So what I want you to notice here, I'm not sure why that froze. What I want you to notice here is what each of these functions do to numbers. So with the y equals 4x plus 2, if I substitute a value in for x in here, like if I did f of 3, for instance, then f of 3 is going to be 4 times 3 plus 2. And the order of operations is that we take the 3, we first multiply it by 4, and then we add 2. So we multiply by 4, add 2. Okay? What I want you to notice is that this function does just the opposite, right? It takes a value and it first subtracts 2. That's the order of operations. You can see it here. You can also see it here. So first we subtract 2, and then we divide by 4. So the f inverse of x, so notice, by the way, that this answer is 14. So what if we did f inverse of 14? So f inverse of x is just 1/4 times x minus 2. So if I do f inverse of 14, I end up with 1/4 times 14 minus 2. So that's 1/4 of 12, which takes us back to 3. So notice that the function itself takes the number 3 and maps it onto 14, right? If we think about it like this, it takes 3, maps it onto 14. That's what the f of x does. And then the f inverse of x takes the 14 and maps it back onto 3. And again, how does it do that? It does it by doing just the opposite. We first multiplied by 4 and then added 2. So to reverse it, what we do is we first take that 2 away, we subtract the 2, and then we divide by 4 to undo the multiplication. So I just want to point that out. Algebraically, if we want to prove that two functions are inverses of one another, then what we need to show is that when you do the composition of the functions, which is what we just did back here, composition of functions is when you do one function and then you follow it with another function. In other words, you take the answer here and you apply another function to that. This is what's called composition of functions. So if you compose the functions f of f inverse of x, it should act like the identity function. The identity function is just the line y equals x. It's the function that maps everything onto itself. The ordered pairs that are on that are, for instance, 1, 1, 2, 2, 3, 3, and so forth. So every value gets mapped onto itself. That's why it's called the identity function. So when we do the composition, it should act like the identity function. When we do the composition here, it should act like the identity function. We're at the f inverse first. And we saw that back here. If I look at what's overall happening with this composition of functions, 3 ends up eventually getting mapped back onto 3. So that's the identity function, when something gets mapped onto itself. So again, I would invite you did this back in chapter 2, I would invite you to turn off your video and give it a try, and then turn your video back on, and I'll walk you through it. Okay, so again, if you are back, then hopefully you have worked through this problem yourself. I just want to remind you that f of x was 4x plus 2, and that f inverse of x was x minus 2 divided by 4. So if I first want to find this one, f of f inverse of x, then what this means is I'm going to take the function f inverse of x, which is this, that's on the inside, and I'm going to substitute it into the f function in for x. I'm going to sub it right in here. So when I do that, I'm going to end up with 4 times, and then in place of the x, I'm putting the quantity x minus 2 over 4 plus 2. And then to simplify that, think of this as 4 over 1. These will divide out, and so I'm left with x minus 2 plus 2, which is just equal to x. So that tells me that when I do the composition of functions in this way, with a function and its inverse, it will behave just like the identity function. It'll map whatever I put in for x, it'll map it right back onto x. But I also have to show that it works the other way. So if I do f inverse of f of x, all right, that means this time that I'm taking, let's see if I can get rid of a few of these things here. Then that means that I'm going to take this function, 4x plus 2, because that's my f of x, and I'm going to sub that in for x over here in place of that. So I'm rewriting this in place of the x. I'm putting 4x plus 2, so I get 4x plus 2, and then I have minus 2 all divided by 4 from here. So when I simplify this one, first order of operations tells me to do the 2 minus 2, so I end up with 4x divided by 4, which of course is equal to x. So again, what we see is that the composition of a function with its inverse in both orders acts like the identity function, and that's an important thing to remember.